Okay. These two sources are in phase. God help us if they're not in phase. They generate a sound wave with a frequency of 625 hertz. Okay, so our wavelength is, let's figure that out. 343, since it's sound, over 625. 343 divided by 625. This is 0.5488 meters. All right. So that is our first step. Is you got to figure out what that wavelength is, right? Okay, and then for point P, okay, we got to figure out the distance A to P, whoops, and B to P, right? Okay, so AP is equal to the square root. We've got to use the distance formula here. Okay, so let's see. In the x direction, it's just 10 away, so 10 squared plus, let's see, I feel like this distance here, we can do this. This distance right here is 3.7 minus 1.2. Minus 1.2. So 3.7 minus 1.2 is 2.5. Okay, so let's figure that out. Square root of 10 squared plus 2.5 squared is 10.30776 meters. And then BP is the square root of, let's see, got to figure this out. So 10 is our x, right? So 10 squared, our y is, got to figure this out. I feel like this distance is 3.7 plus 1.2, right? So that is 4.9, is it? I want to say 4.9. 1.2 plus 3.7. 4.9, of course. Okay, we can do this. We can do it. So now I'm going to just grab that same thing I just got. Instead of 2.5, I'm going to make it 4.9. And this one is 11.13597 meters, right? So the difference in length is 11.136 roughly minus 10.308. So I'm going to go this guy minus that guy. And I get that that's 0.8282 meters. And then how many wavelengths is it? The wave number is just going to be the difference in length over lambda, right? So it's 0.8282 over 0.5488. Higher math. Okay, so that guy divided by 0.5488. And I get 1.509 wavelengths, okay? So because it's closer to 0.5, that makes this destructive. Okay. I know it's really like 1.51. It's not exactly 0.5, but it's closer to destructive than constructive. Okay. All right. Now we're ready to look at point Q. You got to mind your P's and Q's. Okay. So for point Q, AQ is equal to, let's see, AQ is the square root of 10 squared. That's how far we are in the x. And then in the y, we're 2.4 plus 1.2, right? So that's 3.6. Okay? Because if we go up to this line here, that's 2.4, and then A is even 1.2 higher than that, right? So the square root of 3.6. This is 10.6283. All right, and then BQ is the square root of 10 squared plus, okay, let's see, 2.4. I feel like we only have to go up 1.2, right? It's going to be 2.4 minus 1.2, which is also 1.2. Okay. So that guy, and then it's just 1.2. And I get 10.00717, right? So our difference in length is just 10.6283 minus 10.717. Oh, 0717, sorry. Okay, so I'm going to take this guy, subtract that guy, and I get that it's 0.5565 meters, right? So then our wavelength, our number of wavelengths is just L, the difference in L over the wavelength. This is our wavelength here, right? So it's just going to be 0.5565 over 0.5488. So divided by 0.5488, and that's 1.014 wavelengths, right? So since that's closer to 0, that makes this constructive. Okay? Yarbly.